So what is the support vector machine? Okay. In the support vector machine, we understand the basic concept what is the support vector machine and how the data point are split, right? And basically why that's used for. So basically this is a supervised machine learning, right? This is a supervised machine learning. No, and you know about that is a three type of machine learning that is supervised, unsupervised, and uh, supervised and reinforcement learning, right? There are three types of learning, and that which we are learn about a supervised machine learning and that support vector, right? And in that support vector, basically use a label data, right? In a support vectors, basically use a label data, and there are two types. Okay, we learn about regression, right? Regression task, classification task, classification task. Similarly, try to understand, in a linear regression, you solve a problem you just solve a problem with a regression problem, right? In logistic regression, you solve a problem of classification models. Similarly, in support vector machine, you solve both a problem, regression problem as well as classification problem. So in that particular case, you have two okay, types of SVM. There are two type of SVM. Uh, Two type of SVM is the SVC. One is the SVC support vector classifier, and second one is the SVR support vector regression. Okay, there are two types of support vector machine. So we will learn and understand one by one. Look at that data frame. Okay, so a data is split something in a different way. Okay, there are data points, there are data all that there are data points in both speeds, and one line is the best. Basically, when you learn about a linear regression, right? In a linear regression, simply your data frame is you know simply your data frame are split something like that, right? That we have a data point, and simply a line passes through this called a best fit line. Similarly, in support vector as well, you will see that line passes through the particular line. Okay, so in that case, this line, this line is called a hyperplane, right? This line called a hyperplane, and similarly, no, this both side of that hyperplane, this two lines. What is this two lines? Why this are generated? Why it used in a support vector machine? So that we'll understand. So this concept, this basically is line called the marginal plane. Okay, this called marginal plane. This is both line. This also called marginal plane. This both line are marginal plane, right? And this distance. Okay. One more thing to understand in this concept. And this distance. Okay. Basically, what is an aim? When we define an aim, first erase it. Okay. And beside the aim, and then understand that um, diagram. This graph is the more with understanding. So in that way, what is the aim when you talk about the aim in support vector machine? So basically, the distance that we have, that distance d, and basically the d dash. So in that particular case, and in that particular case, what is the aim in support vector machine? To maximize that distance. maximize that distance. That is the that is your aim to maximize this distance in support vector, right? What is support vector? Basically, this this attach with a basically more, in between the that's point that come here in both the side, right? And some other point that's point. This called a that's point called a support vector. Okay. So we what is the aim? Aim to maximize this distance. Okay, basically this distance in support vectors. So aim is to maximize this distance for helping us to grow our model training and basically the model train well and which is output or accuracy good when you the when you maximize that distance. What is the aim? Is maximize that distance. And there are many things. There are many things. Okay. That's why I hope that's the basic introduction of a support vector. And one more thing, understanding for a 2D plane, you simply draw a line, right? Simply draw. This is the 2D plane, and that will have some data points, something like that. That they have a data points, something like that, and we simply draw a hyperplane and a marginal plane, right? Marginal plane. So when you draw a 2D plane, so is a 2D plane look like something that, and similarly when you draw a 3D plane, when you draw a 3D plane, so a 3D plane is looking like a that that type of, okay. That's we have our data point. We understand all the concept how to convert it 1D into 2D, and then sometimes the plane are merged together, then you split that both side. So all concepts we will learn in the next video. But when you draw a 3D plane, so 3D planes look like something that, okay. So this is a 3D plane, okay, and some with a support that is a marginal plane is will in a 3D direction, okay. So this you are for x1, x2, and x3. So this is a for support vector machine, and for 2D plane and 3D plane, we will understand this concept. Okay. In next video, we will understand about what is soft margin and hard margin. Because in a real world data set, there are some problems. Some overlap the data in between in the marginal plane, right? So that's why we learn in next video soft margin and hard margin.